The future value formula, we need to look at the variables we're going to be dealing with. FV is future value, PV is a present value, R, or lowercase I, is the interest rate as a decimal. N is the compound periods, and T is the time in years. The future value formula is given as FV equals PV times 1 plus R over N raised to the N times T. Now when we deal with compound periods, first compound period we're going to look at is annual compounding period. That means N is equal to 1. Then we look at semi-annual. That means N is equal to 2. We have quarterly, N equal 4. Monthly, N equal to 12. Pretty rarely used, but could be used. Weekly is N equals 52. And then daily, N equals 365. Using 365 instead of 366 every fourth year just keeps things a little more simple if we don't reference the leap year. We'll go through a little guidelines using the finance solver when we put this into the calculator. The finance solver, there are several things you need to remember. First, future value and present value will always be the opposite signs. Second, payments per year and compound periods per year will always be equal. And this is just simply for our purposes. Third, I, capital I in this case, will not be converted into a decimal form, so it means it is the interest rate as its percent value. N is the compound periods times the time. Notice it's capital N. Now when we're saving money and we're incorporating the payment, present value and the regular payment are going to be the same sign. Whenever we are borrowing money or paying off a loan, trying to pay off the financing of a car, something like that, future value is going to be equal to 0, and it's only going to be equal to 0 if you're paying off like a vehicle or paying off a credit card. Present value and payment are going to be opposite signs if we're borrowing money. Now, looking at some of the finance solver basics. The first basic type of question we're going to have here, Hilda wants to have $10,000 in 10 years after investing into an account that earns 3.6% interest compounded monthly. So what we want to do with that information is we want to put it into the TVM solver, into the calculator, and just identify some of the basic rules that we just talked about. So here in our calculator, we're doing a standard calculator. We'll go to menu, finance, and then the first option is finance solver. And here you see all those same variables we just discussed. So when we calculate N is the compound periods times the years. So 10 times monthly is 12, gives us 120. The interest rate was 3.6 as its percent value. We do not know the present value. There is no payment in this case because it's just a basic question, but we want to have $10,000 as our future value. The payments per year and the compound periods per year are both 12, and then you go down and hit enter on present value. And you see that she needs to deposit $6,980.52 in order to have $10,000 in 10 years. Now, again, notice future value, present value are opposite signs. If I was to go down to future value, make it negative, and then solve for present value, it would give me the exact same absolute value answer. It just, in this case, it gives me a positive because present value and future value need to be opposite signs. Just another quick example here. Juan wants to invest $1,250 into an account that earns 2.34% interest, compounded monthly. How many years will it take for the account to have a value of $5,000? So if we take this information and just overwrite the TVM solver, we don't know N, so it's 0. Interest is 2.34. Present value is negative 1,250. Future value is 5,000. Now you notice we get approximately 712 for N, so we have to divide that by the compound periods, and that's going to give us a value of 59.33. So basically 60 years in order to get $5,000. Now, if we look at the finance solver in terms of investing as we go, here, Alicia wants to deposit $3,000 into an account earning 4.25% interest compounded monthly. She knows she's going to have to continue depositing regularly in order to make her investment grow more rapidly. So she decides to deposit $100 each month. How much will her investment be worth in 15 years. So if we go back to the finance solver, we're going to have to input this information, 15 years, and we're talking about monthly payments and monthly compounded interest. So 15 years times 12 is going to give us our value for N. And that's going to give us 180 for N. Our interest is 4.25. Our present value is $3,000. Our payment is $100. And we calculate future value. That gives us $30,787 and about 42 cents. Now notice present value and payment must be the same. Then we want to look at paying back borrowed money. So here Johnny buys a car that costs $34,599. He financed the car for 60 months at 5.75% interest. What will his approximate monthly payment be in order to pay off this vehicle? So with 60 months, that is N. So N is 60, the interest is 5.75. Here the present value is how much the car is worth, so $34,599. The payment we don't know, and we want to pay off the car, so future value is 0. When you calculate the payment, you get negative $664.88. Notice payment and present value need to be opposite signs here. And that is time value of money.